Well, Max there again, welcome back to the shop. So, on with our tailstock quill this week. So, have a piece of material there, it's a bit of 30mm diameter 1020 bright mild steel bar. So, we'll turn this down to 25mm and get the thread cut in one end, hole drilled through and a Morse taper in the other end. So, off to the lathe. Right, we'll get our piece chucked up and we'll get a centre in it. So we need 150 sticking out, something like that, and a bit. See how it's running. That'll be fine. Get a centre drill in. Right, we'll get a centre set up and we'll turn the OD down to 25mm. Okay, we've got a new centre here. It's not an expensive one, this is just a cheapie. An expensive one here in Australia, a good quality one. You know, for a Morse taper 3 centre you're not going to get much change out of $500. So this is a stopgap interim cheapie, and I already don't like it because the outside goes round and round on the body there, and I just don't like that style. So, anyway, let's get turning. Oh, this material, it's 1030 bar. It's notoriously shit stuff to machine. So we'll see how we go. Okay, I'll just show you that. Actually, you can see it there in the angle you're on. So, in that first half, we were turning that at 900 RPM, and we stepped up to 1400. So you can see the difference in finish. So that's actually not too bad, that. So, and that was 1mm off the diameter. So we'll go and we'll take 2mm off the diameter in this cut and see what happens. Finish is about the same. I'm not liking it, there's too many hot bits coming at me. So we'll go back, we'll just stick with 1mm. There's only a couple of them to do, so Yeah, we've only got a couple of cuts to go, and we're down to size on here, so I'm not worried about those long chips. It's not worth pursuing. Okay, we've got 0.91 millimetres to go, so I'll just take 0.5 mil and then we'll check it with the micrometer. Bit of heat in that, so we'll just cool him off. It's got it. We'll get micrometer out and see where we are exactly. Before I can get a size, there's a bit of rust and shit on the inside and on the bore where the quill goes. So we'll just get that cleaned out. With a WD and a couple of runs with a flat wheel should do it. That looks pretty good. So this torch that I got a while back, this Olight Batten 3, bloody brilliant. It's gone through the walls and it just keeps going. Great little torch anyway. Okay, we'll see if we can get a size on this bore, see what's going on. Just going to use a little telescopic gauge. We'll check it in a few different locations. So we're 25.03 and 25. I think it's seemed a bit looser down this end. Twenty-five point oh three five. 25.03 to 25.035. Okay, so we've got 0.42 to come off. So if I go for 0.4, that should be alright. There's about 15 microns taper in this, which is nothing. So I'll take 0.4 off, and that should be our finishing cut. A little bit furry. I probably should have put some cutting oil on that. And just quickly knock the fluff off. Right. Before I did that last cut, I did swap the insert out for a 0.04 nose radius insert. Well, that's a finishing insert, whereas previously we had a 0.08 nose radius tool in there. Okay, so we've got 25.035. The other end 25.036-ish, maybe a micron or two larger. That's nothing. Or 035, yeah, no, there's nothing in that. So that's actually size for size for our bore at the moment. So what I'm going to do is we've got a hole to bore all the way through, as deep as we can, and the Morse taper to cut in this end here. So we'll get all that sorted out. We will have to run a steady rest on the end, and then once we've done that Morse taper and our machining operations on the other end, we'll just polish a bit of clearance on the shaft here. You know, maybe polish 3/4 of a thou off it, and I think we'll be good to go. So I'll get set up with a drill and do this hole. Okay, we'll set our steady rest while we've got the centre still in, so we know we're not going to influence the shaft in any way. So, close the lid down, start the lathe up, chuck a bit of oil on it, slowly bring the fingers in till they make contact. Okay, make sure it's still nice and free, we haven't over tightened it. So we can remove our tailstock out of the way. We'll get a drill bit set up. will be using coolant. Well, that's it, our drill bit's bottomed out, we're at full depth. So we've come right up to this shoulder here. So that should give us just enough hole. Right, we'll get a boring bar set up now. We'll start nibbling away at this Morse taper. When I say nibbling away, that's exactly what we're going to be doing, because we've got a very thin bar and a lot of overhang. This is where a carbide shank bar would be ideal, but we can only use what we've got. So unfortunately too, we're going to have to change our compound slide. This is set right on the angle for the thread, but that's just the way the cookie crumbles. So we've got to alter that to a Morse taper setting. Okay, let's get back into it. Here's our job on the floor, still in the chuck, and the steady rest. I had to take them out because I had some other urgent jobs came in that I had to do, so we'll get this reset back up and we'll show you how we set our taper. Right, we've got our chuck back on the lathe, as you can see, so I'll show you how I set my compound slide to cut our Morse taper socket. It's quite straightforward. So number 2 Morse taper, approximate angle, included angle is around about 3 degrees or so. So we'll go half of that. So I'll just use my torch because it's easier to see. Angle my compound, and then make sure we go the right way. I'm going to angle it as close as I can get it, just there like that, to 1.5 degrees. Yes, that's about pretty close. So I'll just give it a light nip. That's all we need to do there. Now, we'll set an indicator up. We'll just put one here. So we've got to get this a lot closer now. So we're dealing with a taper per inch reading, so we need to make sure our indicator is right on centre height. Quite often I use the side of the chuck if your workpiece is true. What you got to make sure, bring you in closer, whatever you're clocking off, it's got to be dead true. Now before we get too involved with our compound adjustment, one thing we have to do, first and foremost, make sure our indicator stylus is on centre. So mine's looking pretty good there. The other thing we have to do is make sure the part that we are indicating is parallel. If there's a taper in there, we just have to compensate for it in our offset. So say for instance the part was 2 thou bigger in diameter there than there. We halve that, so we deduct 1 thou off our taper per inch reading. So in our case, over 2 inches of travel is what we're going to be measuring. We have 0.04995 of indicator travel over a 2-inch length. Now, say for argument's sake, at the end of our 2 inches of travel, there was an increase, say 2 thou in diameter. So we would then read, instead of 0.04995, we would then read our indicator reading as 0.04895, just to compensate for the taper in the shaft. But in our case here, there's nothing in it, so we're good to go. Now the only part of this job that I do convert to metric is the 2-inch distance that we're going to travel along to clock up our taper. So we just convert the 2 inches to metric, which is 50.8 millimeters. Reason being is the dials on my lathe, the imperial dials, one revolution is 118 thou. It's a bit of a mouthful to contend with, whereas on the metric side, one revolution is 3 millimeters, which is straightforward. So we'll get the compound wound back all the way. We'll come up to a 0 mark. So on this lathe, 16 revolutions will get us to 48 millimeters, and then I just advance another 2.8 millimeters. And I think we checked this before. It's looking just a fraction high. Okay, we're good there. This is just a little lightweight steel rule. It's a little Starrett. What is it? A number 33-8R. Very thin little lightweight ruler, ideal for that sort of job. Okay, so what we do now is we wind in till we get a 0 on our indicator. We've got 0 on our compound. So we advance forward 50.8 millimeters. So okay, there's 48 millimeters, 49, 50 millimeters, 50.8 millimeters. So we've come round 25, 30, 35, 40, 44 thou. So we've got to go nearly to 50 thou. So we'll just jiggle our compound this way. I'll go probably 5 thou past it. Come back to our starting point. Zero our compound. Re-zero our dial, we'll go again. So 48, 49, 50, 50.8. Okay, we're on 47.5. We've still got a little bit to go. We'll bring it round to the 5 thou mark again the other way. What you don't want to do is go too far and overshoot, because then you end up chasing your tail. Just a little bit at a time will get you there. Okay, re-zero. Re-zero. Go again. Uh, 50.8. Okay, so we've overshot now by 1/4 of a thou. Which is not what I wanted to do, but I'll just take it back a hair. Re-zero. Hopefully we're there this time. Okay, I think we're 0.04995, so that's 49 and 9.5 tenths. I think we've nailed it. Let's swing you in and see what you reckon. Okay, we're a hair under the 50 thou mark, so we're good to go. So when we lock our compound down, we just got to go very gently, one side to the other, making sure that needle doesn't move, which it didn't. Okay, so we can put a tool in now and cut our taper. Now the tool we're going to use to cut the taper, it's an old Ifanger threading bar. It's been already previously ground down and spots in its life. It's had a miserable life, but it's been done for a reason, to get into tight spots, as we do. I do have another one which is completely unmolested. I don't know if you have ever seen these before. Ifanger series of boring bars. They have a screw-on tip and the thread profile ground in like a radial, relieved radial fashion around the outside. So you can just keep sharpening your top edge, and as you sharpen it and as it wears, you just keep rotating the bar around to get the full thread profile. Now these are just a threaded insert with the full thread profile. Sorry, it's a bit hard to see, this camera's not picking it up very well. So that's what we're going to use to bore the taper, and the reason why I've gone for this is high speed steel. We want to keep our tool pressure to an absolute minimum, being how the minor diameter of the number 2 Morse taper is so small. So if you get any deflection with that, you're not going to get a true taper, you're going to get an egg, or an hourglass or an egg shaped bloody thing. So anyway, if I'm going to get any trouble with it, I suspect it's going to be down the smaller end of the bore, and it's that small you can't access it. You could probably put a piece of emery paper on a small diamond a bit of rod and try and polish it up a bit if you need to go that way. But I do have a backup reamer. This is my backup plan. It's just a number 2 Morse taper roughing reamer. I don't have a finishing reamer, but so this could get us out of the poo if required. So anyway, I got home the other night and there was a letter from Houston, Texas in the mailbox. So that's old Harold from ARW. He's rebranded his channel from Amateur Redneck Workshop to ARW, and he does bits and pieces on his channel, still playing with his PM milling machine. And what he does have is a good live stream. In the US it's on a Sunday. I'm not sure what time on a Sunday, but when we get it here, when it comes to here in Perth, it's very early Monday morning as I'm heading out the door on the way to work. So when I do watch it, it's later on, so I never get the chance to drop in with any comments. So yeah, so I've got his other sticker. He sent me his round one I've got there, and a square one on the door, which is down there. So that's his square one on the door, on my toolbox door. So next episode we'll get this boring bar set up and we'll knock this taper out, and hopefully we'll get started a fair way into the thread and try and knock most of this tailstock quill off. So anyway, thanks for watching. Hopefully you might have picked something up from this video, especially about the precision method I use to set a taper with the compound slide. So anyway, cheers. Thanks for watching, and yeah, hopefully catch you in the next video. Take care.